Hello. My name is Mark Suter. I am a computer science teacher at a high school in Ohio. I teach game design and a whole bunch of other fun classes, intro to programming. And I'm going to let Melissa from Unity first say something. Melissa?
Yeah, hi. Sorry, bear with me here as I found some good lighting. Welcome, everyone. Thank you so much for joining us today. And thank you, Mark, for leading us through this webinar. Thanks also to Ready for bringing us all together. My name's Melissa Oldrin, and I lead our education programs at Unity Technologies. And I'm joined by my colleague, Rong Zhang, who's on the line. So if you have any questions for us while we're all here together, please speak up in the questions and chat windows. We'd be happy to answer. Many of you have probably heard of Unity. Maybe you're already Unity creators yourself. If you haven't heard of us, Unity is a leading 2D, 3D, virtual and augmented reality engine that's behind the majority of games and interactive development. Ready is a great place to begin your journey into interactive game development. And once you're at a good point in your learning, you can migrate your Ready development into Unity, where you can add more complex motion, graphics, and more interactivity. There are many activities you can do on Ready's platform that will take you to Unity, and there are tons of resources available to learn Unity, and that's what Mark's shown right here. Take a look at our Learn website. That's unity3d.com/learn/tutorials. You can also access some other educational materials on our Learn website there. These are a great place to start. So tonight's webinar will also be a great way to just jump into Ready and to Unity. Thank you all for joining and for showing your spirit for the Global Hour of Code. And from there, I'll turn it over to you, Mark.
All right. Thank you, Melissa. So I am, as a computer science teacher, I teach high school students. And I'm going to be showing you how you can meet some of the standards and stuff like that. But whenever I talk to students, one of the most least motivating thing is to tell the students, hey, we're going to meet a bunch of standards, and that nobody cares, right? So I'm going to be speaking to the teacher audience here. I went ahead and I threw some visuals together. Nobody likes PowerPoint, so I used Google Slides. But this is just more for your reference later. But I wanted to let this kind of guide the conversation a little bit. And I have a couple of links I'm going to throw in here into the chat window. Bear with the, sorry, it's going to jump in there and a whole bunch of windows come up there. But the first one is just those slides there, which has a link to the various standards that I'm going to be describing there. I'm going to go back into screen share mode. But basically, game design is computer science. Okay, it contains all of these lovely things like inside of a cereal box, right? It's not just making video games. And there's so many reasons to do this because we're leveraging the natural interest that students have, right? In computer science, it's disappointingly low percentage are female. Even some of the largest companies, like the company that probably makes the router that you have at your house, their percentage is around 9 to 10%. They're trying to get it up to 14 or 15% female software engineers, computer scientists. But when it comes to playing games, there is about, it's much more even, 50-50, right? A lot of females play games, a lot of males play games, so we want to leverage that. So why not use games to be an intro to that computer science? And the reason when we're going to start with Ready is when students are brand new, it doesn't matter so much the syntax. Like when you're first learning English and a small child begins speaking, you don't correct them when they use the wrong phrase when they're an infant and they're talking. You say, well, I'm sorry, 1-year-old, you're using bad grammar, right? The concepts are what are so important. And that's why Ready is a great starting point for this. When you're ready to make that blockbuster game, that's when you shift things into Unity and start learning more of, say, the C# code, and you really get into the syntax because you need that to be able to make those kinds of games. What we're going to be looking at is going to be some standards from the Computer Science Teachers Association, and then actually making this game here, which is going to be something along these lines where, I'm not very good at it. But you're a dragon, you're flapping up and down, hitting the space bar. And I'll go through the entire process of making this game tomorrow night during that webinar. But tonight I'm really going to be talking about how I teach this to my students and how you might also do the same. So, and also if you have questions, please throw them into the chat, because the part of webinars that really make these things interesting and helpful to you is that when things cross your mind, you throw those questions out there. And I know Christina or Melissa jump on and interrupt me and say, whoa, hey, Mark, hold on, we got some questions here. So that's important. I think that interaction is important. So when you look at the computer science teacher's definition, right, you can read that. But if we break that down into parts, how are we actually meeting these things? We're using a computer to solve a problem. Say our problem is to, in our game of codes game here, when you hit the space bar, it adds upwards force and it flies. So we're using the computer, we're using the simulation, an automated series of steps. Well, we're going to be looking at the if this, then that. In the back side of this, if we look at the little stoplight here, and I'll give you an overview here shortly, but inside of here is a whole bunch of little steps. So we say, okay, when the system, every single frame of this game, we want to set these little graphics to be at this circle, which is going to allow the up and down graphic to look like it's in the same spot, which is why it looks like it's doing it correctly when you do this up and down. The circle here is actually not visible. You would just simply hide this, but it's not a big deal that you see it now. I just leave it on there so that you can see what's going on in the background. So going back to here, through an automated series of steps, that's what those steps are. An algorithm is simply a series of steps. The example I like to use when I'm teaching this is I say, have you ever made cookies? Well, yeah, I've made cookies. So when you make, let's say, butterscotch cookies, which are my favorite, you basically follow a recipe every time to solve that problem. Now, you can substitute different, say you're making a double batch. You multiply all of those values times 2, right? 2 cups of flour instead of 1. And that's just a series of steps. That's an algorithm. And then you can also transfer that to other problems, making other things like cakes and cupcakes and anything else you make in the oven. I don't do a lot of cooking. I cook bacon in the morning sometimes, though. I know you need that. Know that. But that's the concept here. So when I teach this, I don't start off showing them slides, by the way. We jump right into it. But I want to give you guys kind of a background of kind of the science that I've developed. I don't know if it's science. I guess it's an algorithm of how I teach it. I use pseudocoding. My students, sometimes when I explain this, they think I say pseudocoding, which is my last name. But pseudocoding is just what it sounds like. It's sort of coding. When they're first learning these computer science concepts, have them explain it to their neighbor, or even in inanimate objects, a stuffed animal. It doesn't matter. It's the act of verbalizing the problem and how you're going to solve it. So in our case, in this game of codes game, I want this circle. Remember, the dragons are following that little circle. I want the circle to start, let's say, right here. So, and you can see it doesn't go here where the circle was. It actually starts up here. So when the game starts, I want to set the circle up here. So that's the problem I'm trying to solve. And by using pseudocode, I'm already starting to write a very primitive form of code. I have students do this either verbally or even writing it down almost as though it's a script to a play. And the more they start to do pseudocode and then go from that into, say, ready, where we're using these drag and drop things, then as they do that more and more, you'll notice that they will start to use phrases that already exist inside the code they're about to write. In other words, they will start to convert things like this into when system starts, set position of circle, things like that, because that is what the system is using inside of here, right? Set the position to an object. So using pseudocode is a great starting point. Now, you'll notice we're talking about starting in ready for people that might be brand new to coding. But then to get that shift into Unity, this is the exact same command in both programs. So in Unity, it would look something like this. When the system starts, a circle's position to be set to negative 2x and positive y of 2. In Unity, I would use something like Visual Studio here, which at first glance looks completely overwhelming. And so I just snipped out this one little part here is what you're seeing there. And all that's saying is when this script starts, I want to set the transform position. And by the way, it looks like a bunch of gobbledygook in there, I realize. But this is Unity. And here's my little circle. And here's the center of my little universe. And when I play it, I want it to go to negative 2x, positive 2y. So when I hit play here, it jumps to that exact position because it's following that little bit of code. And so its transform position, of course, is just the transform here, and its position is this. So you don't need to really follow that too far other than to say that that is the same command between both programs. And so you can see where there's this graduation from ready straight into Unity, and why that's somewhat of a seamless transition because they use the same terminologies and sequencing of logic. So that's really all I wanted to show you to start off with. The resources that we looked at here on the Unity Learn page, the Space Chicken is a series that we've done together that does exactly that. You build the game in Ready, then you build the whole game in Unity too. And so you can see all of those overlapping elements, which is a great way to get from one to the other. Let's see, let me go back to here real quick. I do have the slides in here. Of course, I forgot to link that. There we go. The CSTA Standards. When you download these, and I'm going to go through these in context as I kind of start to make the game, the little highlights have little comments that I've made for them. So what you're looking at here are the Computer Science Teachers Association's, it's kind of their summary, their grid of standards. There's a full version that's like 40 pages long, but this is kind of the short and sweet version. And over on the left, you're looking at kind of the overarching themes, concepts, I guess. And how, when we're teaching game design, how are we actually even meeting any of these standards? And I'll look at this first one, and then I'm actually going to jump into how I would start making the game, and then I'll kind of come back and forth here. But explaining how abstractions, I'll come back to that, hide the underlying, basically, how does it hide behind the curtain, right? In Wizard of Oz, there's all these kinds of things happening. Pay no attention to the man behind the curtain. Well, that's kind of what we're doing here in Ready, right? We're doing very overly simplified little commands, and it's doing all kinds of things in the background. We just may not realize it. And so in abstraction is essentially taking a overarching concept and basically breaking it down into smaller pieces. So I think I actually have one in here. But if I were to say, well, I want player one, I want the person with the most points to win in a basketball game. Say you're making a basketball game. Well, that's a high level concept. We need to abstract that down smaller and say, well, how many points does player one have? How many does player two have? Is player one greater than player two's score? And then that player wins. And so it's just breaking down those problems into smaller, more digestible pieces. Now, I want to jump into Ready Maker because I want to show you parts of making the game. And we may not get through all of this, and that's not critical because once you kind of see the pattern, you can follow the rest from there. But this is Ready Maker. And a quick overview of the platform, this kind of white area here. In fact, I'm going to change the background of this so you can see the background a little bit better. You hit the plus sign there. I'm going to go to backgrounds and add the ice wall right in here. And you notice these are all like large buttons. And the reason for that is you can develop both on mobile, on a phone, a Chromebook, any computer, of course, Mac or PC, or you can develop on all of those. So that's why they're kind of click and hold type gestures. So this is where you add elements to the stage. These are the events, of course, that you saw in the finished version that we'll get to. The settings here, basically the saving here, which definitely I want to save the cover itself, which is like the icon. So if you made an app, it would be the icon of that app. And you always want to be saving. It's what I teach my students as well. Has that little load thing there so you know you have it saved. This is also where you would do your sharing to have other people play it, as well as exit out of here and go look at kind of your library of everything you've made. So here's the previous one I made, and here's the one that I just forgot to name here. Always name your files is what I tell my kids, right? And then I'm often the one that forgets to do that. But we have our zoom in and zoom out. This is basically our entire stage. And this area here, the canvas that we're actually working on, is what the user would see on their screen. So if you have something outside of that, the user won't even see that part. Let's go ahead and add that circle part so I have something to modify here. But under basic shapes here, I'm just going to throw in a circle. Close that out of here. When you click an object, you have a whole bunch of new little fun buttons over here. The appearance has all your basic things like the size, width, and height. Its location, or I'm sorry, dimensions here. Width, height. No, that is location. Sorry. And then it's rotation. Solid, whether other things are going to physically run into it or not. Various things like, is it transparent or not? Do you want to recolor it? Whoa, it doesn't do much when you rotate a circle, does it? And then the colliders, which we'll get to later. Physics, which we are going to apply because this thing is sort of falling through the floor, falling towards the bottom there. And behaviors. Behaviors are essentially a bunch of pre-built actions. So if I want it to fly in one direction with a speed, we could add a bullet behavior. Or if I want to be able to use the WASD keys and the arrow keys, we could use the control pad. There's a whole bunch of pre-built behaviors that you can use, and then you combine those in creative ways to make video games. Effects are just what they sound like. Fireworks and other kinds of things, splatter effects. And then audio is what you think it is. classes, yeah, we do use those in this one. If you want to apply something and say, well, if my dragon collides with any of those ice shards that you saw in the example one here, these little ice shards that were flying out, you don't want to say, well, if I collide with the first one, I die, or if I collide with the second one, I die, and if I collide with the third, right, it gets, that's not a good idea. So you would just say, well, if I collide with any of these shards of ice, right, and that's where a class would come into play. You would just create a class for that, and then you say, I can, if I collide with anything that has that class. And I think I heard a chat bubble thing going off. Let me jump back over there just real quick, and then I'll come back in. Okay.
That was probably me. We had a question about learning C# for Unity development, and I'm just plugging in some resources for that. Great question.
Excellent. Great. Good questions. Keep those coming. I should probably go back and share my screen then, shouldn't I? You don't want to see me. You want to see this. Okay. So the tutorial that we're actually, I'm going to be showing you for the hour of code that I'll go through the entire thing tomorrow. You can direct your students towards the getready.io website. This is the main website for that. Underneath the Learn section, which also follows the Unity naming of the Learn section there, there's kind of a bunch of little animations of like, well, what does the bullet behavior do? And this is really a great quick reference for those types of things. And it goes through little animated GIFs of all of those things. If you scroll past those, that's where it gets right into little mini projects. And we're looking at the Game of Codes one. Now, what this is based off of is kind of a Flappy Bird. So if you've never visited this, this is where I assign the student's favorite homework of, I need you to go home and play video games, at which point they tell their parents, Mr. Suter told us to go play video games, and they go try and play like Call of Duty or something, but they don't tell them that. I actually sent them here. Flappybird.io, it's exactly what you think it is. If you've never played it before, it's actually a good idea to play it ahead of time so that you can kind of see, well, what is this game a spin-off of, right? We're not going to have the dragon flying into pipes. We're going to have things flying at it, right? So the only control is you need to tap the button for it to fly. And getting students familiar with what is the end goal here, what is the objective, and what is this a spin-off of? I usually take them and kind of show them something like that. Back here, there is a 6-minute video here, which is actually a really good video. It's how I learned to do this the first time through. There's no narration to it. So if you want full narration of it, I would use the one that I'm going to be doing tomorrow night as far as the whole commentary part. But the part that I want to show you first is just kind of the visual technical side of it. It gives you all the different graphics that you're going to need, of course, goes through into the game layout. These two things are going to be sitting on the circle and following the circle constantly. So you only have to move one thing. Otherwise, you'd have to say move this and move this. Well, you can just say move this because these A and B are following C, which again is kind of an abstraction. Adding in the circle, let's go ahead and do a couple of these things so you can see step by step what those look like. Adding in the circle, we have that. We're going to turn on physics. We're going to add a behavior, and we're going to drop the opacity. So as similar to as you saw before, I have this circle. It's way too large, so I can resize it in the appearance, or you can grab a hold of this here. But basically, I want to drop the opacity down just to make sure that I can see the dragons are following the circle, and then I'll drop it all the way down to 0 once we're all done with everything. But so again, the behaviors, we want the behavior of jump, which I'll show you what that actually does. I'm going to leave these things alone. But if you hit play right now, you'll notice we already have that part done where it basically falls, right? And it has this button here that I can click on with my mouse, or if I was playing this on mobile, you could tap it with your finger. I'm hitting that there, or I can hit the space bar. Now, of course, I can fall off the screen right now, but all of that was done with one behavior. And what I would encourage students to do is play with the behaviors. If this is the first thing they make, one of my favorite things to do is to say, okay, I do this in PowerPoint too. I tell them to make the world's worst PowerPoint. It's actually my first assignment in almost any software is I want you to make the most hideous thing you can make using all of the, if it's PowerPoint, if using all of the animations and all of the, it's hideous. It's absolutely horrid to look at. But what's fun, of course, is tell them use all the behaviors, try and use every single one. And what they start doing is instead of doing this, you know how they don't think for themselves. As soon as you give them, if you were to print this out or give them this as a link, what's the first thing that they do? They do step one, right? The jump behavior, put it in a circle. It's essentially kind of a recipe, but they don't think for themselves anymore. And so this is a great example of creating something so they have something tangible, right? And why would you even use the jump behavior, right? It gives them a reason to. But if you have the extra time, either right after or right before this assignment, give them the assignment of, I want you to go in there and I want you to use all these hideous, they're not hideous, they're actually really great. But when you apply too many of them, you can add multiple behaviors to things. But for instance, I want to add the jump behavior, but I also want to add a hinge behavior. So it's going to hook onto this other piece and you can swing things around. And actually, do I have time? I think I might have time. Can I show you really quick what that looks like? Because I actually made something that has a whole bunch of these things. I'm going to do it just because you need to see what this does. Oh, don't forget to save, guys. Don't forget to save. Bad idea. Name it again. It's going to bother me. Game of codes. About 0.2. I always have them do these kind of versioning things too, because I guess you could say it's 1.2. Versioning and subversions. This is still version 1, but I'm going to make it a little bit different. Let's say, or I made updates to it. You would just change this .2 or .25, .26, .27. Anyways, probably save it again. Now I have tons of versions of things because you can see I version things and as I go, I build different things. Coordinates and ready is also, I'll pop that one up real quick too. Just to show you when we're doing the X and Y axis, it's just like you would think it is, but the outside axis on the X is about 3 and -3, and then on the Y is about 1.75 and -1.75. Also handy to know. I shared that one in the Ready forums, in the Look What I Made thing. I know, I'm sorry, I'm kind of jumping around here, but this is all relevant things. Oops, used to just clicking and dragging. The forum is really amazing. There's the Look What I Made. I am a garlic suitor in here. So look for me in there. There's some things I put in there, but that's where I put the coordinates one. And I want to show you I have 5 pages of projects. That's amazing. There's there it is, behaviors demo. I'm going to go share this one in the Ready forum there. So I went through and I added basically everything. So when you hit play, all kinds of things happen. Well, there's that bullet behavior on that little symbol. There's the control pad. I'm using the WASD, but I can't like click and drag that or anything. but I can click and drag the little chicken, the chick. This fade, right when I played it, there was a fade effect that happened there. The hinge with motor is actually kind of cool because you can do simulations of real world objects, which actually meets one of the CSTA standards, right? You could have the moon going around the Earth and the Earth going around the sun. I think that's how that works, right? Heliocentric. I hope that's right. The join, I don't know if you noticed, but right when I hit play, this guy was like joined to the cat. He's kind of creepy, but I guess that's his pet cat. I can click and drag these things. And oh, no, I'm sorry. This is the move towards. He's moving towards the cat. The cat is joined to the elephant. So you can see where this would add some really interesting game behaviors. The joint is really neat because you can affect how much like spring action it has. You could set this up to be like a little baseball game. And this is like your swinging bat. Instead of just doing the old press A to swing, right? You can add a lot of different behaviors in unique ways. Oh, rubber band, that one's kind of cool. It gets kind of out of hand if you start swinging wildly. Woo! It's going all over. It's over now. Anyways, so I had to show that because you can kind of see what behaviors do and how quickly you could make a game. And really, even if your kids are like, oh, I'm good with Ready, I'm ready to move into Unity, go ahead and still have them prototype their game that they're going to make in Unity. I'm sorry, that's getting kind of annoying, isn't it? Have them prototype their game in Ready before they even jump into Unity, because you can prototype so quickly. If they're going to make a platformer like Super Mario Brothers 5, the super hidden levels, well, they might prototype it in here and make kind of a rough draft of what they're going to make in Unity, and then they could shift into Unity and make the entire full version that they put on the App Store and all that kind of stuff, which actually I guess you could make the whole thing in Ready too. But Unity would extend your capabilities even further yet. So I hope that wasn't too much of a detour, but I think it's always nice to see what can you do with all of those behaviors, because just looking at the behaviors doesn't really give you that great of a feel for it. Now, going back to, we're done with that. We are back in here. We've got this first part done. Step 2, we're going to throw in a square, not solid. Actually, the circle shouldn't be solid either. And we're going to add a bullet behavior. Whoops. Sorry. Square. Bullet behaviors. So again, we're adding an asset. So you can upload your own. You can jump right into Jiffy and search for animated GIFs. Yes, I say GIFs instead of GIF because the creator that created the software, the format said GIF. I guess that's a ginormous privilege he has. Basic shapes is exactly what you would think it would be. Artwork, you got 700 and some different little artwork pieces, but under basic shapes is where we're going to be at. Does it matter that you use a square? No, not at all. It just makes it easier to reference, because this is actually going to act as the little spawner, which in Unity they would call it instantiate, which is just a fancy word for spawning. So this is going to be spawning those ice shards. And here's a great opportunity for pseudocode. Here's what I want it to happen. And a student will often describe things like this to me, and this is how we can communicate with each other. They'll say, well, I want this to kind of bounce up and down like this. And I say, okay, so you want it to move in a straight line with a certain speed or velocity. Well, yeah, okay. And then I want it to change directions. Okay, well, we can change its directions through the code, through the events. So what we want to do is just add a bullet behavior to this for now, and then we'll change the direction of that later through the code. Okay, and we don't want it to bonk into things, so we don't want it to be solid. Okay, so there's that. Our behavior, we're just going to throw a bullet behavior on there, and I want it to go straight up. So I'm going to set that to 90. Speed of, I don't know, did it tell me back here? Probably. I don't have this whole thing memorized. Oh, set to Oh, 90 degrees, yeah. Anyways, you can adjust these things, of course. So if I pull this into the scene so you can actually see it a little better, when you hit play, pew, goes flying off. I can hit spacebar to make my circle guy float. But then later on, you'll notice that, and I know we don't have enough time to make this entire thing, but basically you throw in the dragons, both are solid off, and then you create an ice class. And I want to show you that part because that's important. So let's throw in an ice staff and let's create a class for it with a bullet behavior. So let's get that part. I want to add some artwork. So I'm in the artwork section and I hit ice. There it is, ice staff. So I'm going to throw that in there. I do not want it to be solid. So I'll select this. Don't want that to be solid. The behavior was a bullet behavior because I want it going to the left. Close that search out of there. Another bullet behavior. I just press and hold that, drag it over there. I want it going to the left in the 180 degrees, somewhere in there. There we go. And I don't remember what speed it was, but as far as the classes go, there isn't a class for that. So you might just create one. Ice. Save. That way, when this spawner spawns a new ice, that one is also part of that class. All of the copies, oops, make sure you click that, otherwise it's not in the class. But all the ones that get created, the copies of that, the clones of that, are also going to be inside of the ice class. So now we have this. Well, because we're going to have the square spawning things, I'm actually going to kind of cheat and put this thing off to the bottom because the player's not going to see it. The square is going to be going up and down and spawning those ice shards. So that's what creating the class looks like. Timers, again, a cool little built-in image. Yeah, that's actually under the plus. That's part of the user interface. It doesn't say on that part right there, but it's, make sure I go into the right thing. You would add that under interface. So there's these cool things on here. I haven't even tried the Arduino thing. If you have an Arduino, I think that would be really cool. That's a whole nother series of fun things, but there's the timer here. But you can add interactive buttons. So when I press blank, it spawns something, or you can make all sorts of old school video games easily that way, but you just throw in a timer and just put it in there, right? Oop. And I've rotated it. Way to go. Woo. I'll just put in like 4x4. Probably shouldn't have rotated it, huh? There we go. Right, built-in timer, ready to go. And then you can say, well, when you die, when this goes off the screen, or any of those things, then you just stop the timer. And so the objective, of course, is to stay alive as long as you can, which is similar to the Flappy Bird, which is get past as many pipes as you can, but the same difference as far as I'm concerned. Yeah, get your background in there. So creating the game events, definitely want to show you these. So we have the circle in there, and this dragon is just going to be following it. That way you don't have to double code everything, right? So you don't have to say, well, when I hit the spacebar, you should move up the Dragon A and the Dragon B, and it just saves you some code. So you can just say, hey, you guys follow the circle, and then I'm going to move the circle, right? You actually might be able to use a join behavior, but we're going to use code in this example. So every frame, system runtime every frame. So let's go in and do that. Of course, we're going to need the dragons first, aren't we? Better do that real quick. I think if you do yeah, there we go. Dragon down, doesn't matter where you place these. Dragon up. Ooh, these guys are way too big. So I'm going to resize one and to a size I like and see what I set it to. So you can see here it's at 0.46. Okay, so let's just decide on like 0.5. That way I can have this guy go to the same thing. That way they're going to be exactly the same size. Very good. They don't have to be right on top of each other right now because they're going to jump onto the circle when the game starts. Okay, we talked about abstraction. We can have as many events as we want. It's a good idea to name what each one of these little bits of code is going to do. And these are, of course, visual representations of the code. It's a kind of a simplification of it. So I might say set dragons to circle, or set position to circle, or whatever. When you click on this first one, these are all context sensitive. So as soon as you click on that one, it's only going to give you relevant options. And in this case, I want to say, well, every frame. Well, that's underneath that's a system thing. So the system runtime, you could say any of these fun things, but like the scene start that I showed you in the slideshow at the beginning, that has the Unity equivalent of that. Remember? But in this case, we want to say when every frame takes place, do what? Well, I want the dragon down. I don't want to change his angle, his appearance. I don't want to clone or destroy a clone. I want to set his position. So something to do with his position. Well, I want to set his position not to a coordinate, but to an object. And then it lists the objects that you have. Well, I want to set it to the circle. And I want the dragon up, position, change, move up, move down, set position to object, circle. So now I've named that little chunk of code, that event, and I've also given it multiple things to do every frame. So you can add as many things as you want it to do every frame. You could keep adding a whole bunch of things and it'll do all of these things every frame. Which if you get carried away with that, it could make your game lag, of course, because you're trying to do too much every single frame. So as soon as I hit play, you'll notice these dragons are no longer here. They're actually with the circle. And uh-oh, what did I do wrong here? Do I got behaviors on these things? No, I don't. Oh, you know what? I think they're colliding with it. I bet that's what I did. Yep, these are solid. They should not be solid. They're trying to react and bounce off of each other, but it doesn't like that. There we go. So you can see the circles there, and I'm leaving it there so you can actually see what we're doing here. But so there we go. We have a really good start to this. I think if you were to teach this, you could probably get the rest of this. Each one of these kind of lays out what you should do for each. This is what makes it animate. So in other words, if you're falling, it looks like one, and if you're not falling, then it goes back to the other one. So it kind of looks like he's flapping his wings. So events, and then export to Unity, which is awesome. A whole nother thing that I could talk about for a while, but I don't want to bore you with it other than to say, let's say I was like, I'm ready to make this an Android app. Sweet. And I think Christina might have, if you haven't already, put in the link to a tutorial that I made for this already. But if you were ready to export this and put it onto your phone or your iPhone, you could hit this export to Unity 3D and just follow the tutorial that we're going to put here in the chat. And you could get it from here in Ready to an app on your phone for free. It's all free. That blows my mind. I don't know if that's really surprising to anybody else, but it just blows my mind. I guess because I've tried to make apps before and it's like really difficult. And then I figured out that you could do this, or I learned about it. I didn't figure it out. I'm not that smart. So that is really amazing to me. Okay. Before I forget, and before we run out of time, I want to make sure that I'm doing due diligence here. So we've talked about how the events are can be abstracted to show, they're basically hiding the they're high level, and we can break them down into simpler things. Now, Designing projects that combine hardware and software components. Of course, we're going from Ready, which is the software, to Unity, which is the software, to create an app, also software, that ends up on a phone or on your computer, et cetera, on the hardware side of things. Actually, you know what? I think this is missing something. Let me go back to that link that I gave you earlier. I'm going to jump into this because I think I'm actually looking at an old version of it. Yeah, there we go. So evaluate the trade-offs. Let me zoom in here, or I'll just download the new version. What do you say? Okay, yeah, that is right. Okay. Trade-offs and where you're storing at. Well, specifically here, your local would be on your computer, right? Please don't let your students ever run software off of the flash drive unless they're prepared to lose it. And I always tell them, if it's on a flash drive, you're using it to transfer from point A to point B. It's not your constant and only storage location. But, you know, it's just my opinion. I've seen too many kids crying over lost projects. Anyways, the advantages of the local, of course, being that you might have greater read and write speeds if you're working in Unity. You definitely want to be working locally. And in ReadyMaker, you know, if you're on the computer, you're working locally. But when you save your app here, of course, when you save it, it's actually syncing it to the cloud. Because remember, we could, oh geez, I didn't even save it. I am that guy. I'm that teacher. It syncs it to the cloud. So there is a remote storage. And what some people don't realize is that in Unity, you have a similar feature. If you're a teacher, you really need to get on their list to get the free teacher professional licenses. This is my home one, so I don't have it on this one. But you can actually just turn on collaboration. And then you can, let's say I turn that on, I can sync it to the cloud, and then I could go to school tomorrow and then download it through this same feature and continue working on this app, this program, which is mind-boggling. Okay, it's not mind-boggling, but it's really convenient. It's like using GitHub, except it's right inside of Unity, and it syncs all the files and everything, which also allows you to put in comments as you sync it. You also have a Unity team, so I can have my students also use and look at each other's, et cetera, et cetera. So they both kind of have that feature, which is awesome. Meeting more standards, clearly named variables. So when in Ready, you can make variables in Ready. Let me go back to here. You can make variables in Ready here. And if you want to start teaching them the right way to name variables, is to say, let me go in here and just make a variable. I clicked on the world thing, game, new variable. And let's say this was player one's score. What you do is do lowercase of the first one, then uppercase the rest of the words. No spaces, no dashes, and consistently use these methods. Lowercase on the first, uppers on the rest for variables. This is called camel case. I don't know the real reason behind it, but what I tell my students, and I tell them I don't know the real reason, but I tell them, imagine like a camel kind of with its head down. It's like lower at the beginning, and then these are like the humps of the camel. And, you know, if you have more words, I don't know, I guess he has more humps. I don't know. But that's called camel casing. And then if you were naming an entire script, like you are working in Unity, which would tie into Microsoft Visual Studio, which is just a software you write the script at. You can use other ones too, but you would use capitals on all of them, which is called Pascal Case. So just teaching them little things like that will ease that transition from ready into Unity. So it makes it much easier on everybody involved. Also using what's called semantics. In other words, if they have a variable, don't let them name it something like variable 2. Well, what is that? Is that a score? Is that a time of day? Is that a health? What is that? No, instead, make them semantic with some sort of meaning behind it so it actually makes sense, right? Little things like that are not only going to meet objectives, right? The whole point of these standards is to uh, basically speed up production and the ability to communicate between different projects and people, etc. So getting them started early on those things is important. Iteratively develop. My friend Steve Isaacs and I, we like to use the word iteration, which is, of course, we'll ignore that part. But the iteration part is you develop it, you test it, you learn from it, and then you develop it some more, you test it, you learn from it, and you continue through those loops, starting out simple, and then building complexity. In Unity, you might start out with what we call gray boxing, which is where even if you're working in 3D, this is in 2D, of course, but if you're working in 3D, I don't even let my students use complex like graphics they found on the internet with complex models, etc. I have them gray box at everything, like literally like gray boxes. Yeah, I mean, they could be spheres and things like that too. But in other words, keep it simple, silly, right? Isn't that called the KISS method? I know it's keep it simple, stupid, but it just sounds mean. But anyways, the compound conditionals, the standard here, including nested loops and compound conditionals. You've seen these things before, or at least the opportunity for these things, because I could say when this circle's position is above something and the circle's appearance is hidden, I don't know. I'm making this up as I go, but you can see these two things together. Both of these have to be true before it will do that. Those, because there's two of them, that's a compound conditional. Or you could change this to or and say, well, if this or that, right? So that's all it is. That's a compound conditional. A great concept when they move into Unity and C#. They don't have to learn what those things are at the same time that they're learning how to write scripts. Oh man, that makes them so far ahead. Modularity, kind of a fancy word. Basically, taking these problems and breaking them into smaller pieces. Well, guess what? You're doing that right here. These little events, each one of these events is modular, right? They're naturally the verb of modulating, I guess. You're breaking it into chunks as you go. And by doing that, they get in these habits, which is good because then they can do that in Unity and in C#. Wonderful things to have down pat when you move into Unity. Getting feedback. So this little thing here is, it kind of looks like a lot, but basically it's asking a series of questions. And I borrowed this from a book. It's kind of some weird symbols in there, but basically Jesse Schell has a book called The Art of Game Design. And in it, he references this guy that says, here are some questions that you could ask people. And you could use a Google Doc or a Google form or just a piece of paper, but it's a way to get feedback and actually then use that to refine your game. I know we're running low on time, but incorporating existing code, media, etc. Well, of course, there is Jiffy that's built into Ready. Using opengameart.org, which is a website. It's basically licensed, not licensed, which is called Creative Commons licensed. There's different licensing Basically, you get free art, music, sound effects, sprite sheets, all that kind of stuff. That's one place to get things. There's a bunch of 3D ones that people that do Unity also would use, but those are great things. Also, using other people's existing things. So if you look into, go out of there. If you look into you can remix other people's projects, right? That is using existing code. So if you look in the featured area, for instance, you could take any one of these featured ones that other people have made, and you could remix that and check out how did they do what they did here. That is a great way to learn things, is looking at how other people did it. I'm going to let that load, but you can remix those. Should pop up here shortly. Distributing tasks. That's as simple as, if somebody wants to specialize in programming, let them do that. Giving them different jobs so that they can accomplish lots of things, different elements of the game. Document programs. Of course, you could use OneNote for Microsoft or Google Docs, or Office, Word online. GitHub is another great place to just put a README file if you're going to be using GitHub. Sync your C# scripts. But most GitHub repositories will have a README. It's just a notepad, of course, but it's a good place to keep track of that and document that. And the last one I'll mention here, the issues of bias and accessibility. So you noticed when we added I'll go to this version. When we added that jump thing, we have this little button here. Well, if there wasn't that little button here, what button would you press on a phone to make him fly? Trying to recover him. What button would you push? Well, you don't have, you have the volume button and the home button, but that's probably not a good idea to necessarily use those in a game. So it wouldn't be very accessible to a mobile user, would it? So they need to have something they can access as well as something convenient for the person on the computer to access. So I'm using the space bar, or I could be clicking on that. And that's in reference to the bias of whether you're on mobile or on PC. And I wonder if that other popped up. Now, I'm hoping there are some questions in there. I love getting good questions. Oops, I jumped in the wrong thing. Ta-da, there it is. See the remix button right there? You click on remix, and hello. Probably doesn't help that I'm trying to screencast at the same time. Let me see if there's any questions in here. Let me stop that screen share briefly. Jump over to here so you don't see the mirror of all kinds of things. Moved to Unity a few weeks ago. Oh, good. Draven moving from Ready into Unity. Excellent. A lot of people are doing this as they get really good at Ready. They're ready to move into Unity to learn actual code. There are some good free, I call them MOOCs also. Those links there are really good ones. If you look up, there's some good YouTube videos on C#. In fact, when I look it up, I usually will look up C# Unity, either C with the pound sign or the word C# with the word Unity. That way you're in the same interface, because there are some subtle differences between just doing C# having nothing to do with Unity and doing C# with Unity. It's almost identical. There are some subtle differences, though, that will make life a lot easier for you if you do it in the same development environment. Others, do we have other questions? Looking through the chat here. Did I miss anything?
I don't think you did.
Great. This is Melissa.
It is Melissa. Hi. So you mentioned the free Unity Pro licenses, and I posted the link to that in the chat. If you are at a school or an educational nonprofit, you can apply for up to 1,000 free Pro licenses for educational usage from Unity. They're good for a year. And each license is worth about $1,500 if you were to buy it. So it's really a great program, and we love to have more people take advantage of it.
That's a lot of dollars worth of licenses.
Yeah, right? The link's right there. Awesome. You apply, and then we receive your application, and we pretty much issue those once we validate that you are a nonprofit organization or an educational institution, and they're yours to install. Pretty simple.
I've never got rejected every year that I apply. And I mean, I get rejected a lot for things. But I've never gotten rejected from getting the free licenses. So I feel pretty good about that. Awesome. Was there anything else, Christina? Are we missing anything? I feel pretty good about that. I think we got a good handle on that. If anybody has questions, reach out through the Ready forums. Really is a good place. There. Awesome. And there'll be another webinar tomorrow evening. And we hope to see you there. That's going to be going through the whole Game of Codes tutorial and building it from start to finish in 1 hour or less.
It'd be great. Thank you so much, Mark. Thanks everybody for joining.
Awesome. Thanks everybody. We'll see you soon.